Hi everybody, today we're going to do a problem about finding trig values given a point on the terminal side of an angle. Our problem says the terminal side of an angle alpha goes through the point 4, -8. Find the values of the 6 trig functions. I'm going to start by drawing this point on a coordinate system. So we can see the point 4, -8 in the 4th quadrant. I'm going to add in the angle and I'm also going to draw a dashed line to the x-axis. Thinking of this as a triangle, I want to fill in the values of our 3 sides. Horizontally, we have a value of 4. Vertically, we have a value of -8. And it's really important that you put the negative sign in with your value. What we need to find is the length of the hypotenuse, so I'm going to call that h this time. To find the value of h, I need to use the Pythagorean theorem. I'll have 4 squared plus -8 squared is equal to h squared. 4 squared is 16. -8 squared is 64. That gives us h squared. 16 plus 64 is equal to 80. That's still h squared. Now I want to take the square root of both sides. Square root of 80, square root of h squared. I don't want to stop there. I don't want to say that h is equal to the square root of 80. I want to reduce this radical. What I think about here is that 80 I could write as 16 times 5. And I use 16 because the square root of 16 is 4, which says I have 4 square root of 5 is equal to h. Now that I have the 3 sides of my triangle, I can find the 6 trig values. Sine of alpha is going to be the opposite, -8, over the hypotenuse, 4 square root of 5. I can reduce this. 4 goes into -8. I get -2 over the square root of 5. Remember, we don't like radicals in the denominator, so I'll multiply by the square root of 5 over the square root of 5. My solution is -2 square root of 5 over 5. Cosine will be the opposite, which is 4, over the hypotenuse, 4 square root of 5. The 4's will cancel, leaving me a 1 in the numerator. 1 over the square root of 5, I'm going to rewrite by multiplying by the square root of 5 over the square root of 5. This gives me the square root of 5 over 5. Tangent of alpha is the opposite, -8 over the adjacent of 4. -8 over 4 gives me -2. Before we talk about secant, cosecant, and cotangent, let's talk about the signs of the quadrants. Remember, in quadrant 1, all trig values are positive. In quadrant 2, sine is positive. In quadrant 3, tangent is positive. And in quadrant 4, cosine is positive. Doing a quick look back, we can see this matches what we have as our solutions because square root of 5 over 5 is positive for cosine. Secant is the reciprocal of cosine. Let's go back to where we started with 4 over 4 square root of 5. I'm going to flip that over. 4 square root of 5 over 4. I'll cancel the 4's and get the square root of 5. Cosecant is the reciprocal of sine. I'll write 4 square root of 5 over -8. 4 still cancels -8 to give me a -2, and I get the square root of 5 over -2, which I'll write as negative square root of 5 over 2. Cotangent of alpha is the reciprocal of tangent. I have 4 over -8, which I write as -1/2.